Hello, my name is Joey Gugliardi, and I'm a senior industrial and systems engineering major here at Liberty University. And this is my final project for Engineering 430, a decision support system for the government when making decisions on tasks. So the problem description is that this is a tool used for the government to prioritize and to choose tasks to complete based on limited resources and various constraints. One of these constraints is that all official commitments of tasks must be kept. Secondly, only one task from a list of mutually exclusive tasks may be chosen. Lastly, the total budget available is a constraint, as government projects often have strict budgets. The goal is to maximize the performance of the system and report back the tasks that should be chosen and how much of the total budget was spent. This is the analytical model. As you can see, it is an optimization problem with the goal of maximizing the score of what the user would rate the different tasks. Like I said, the constraints is that it must be less than the total budget allowed. The must-funded tasks must be kept, as the government has some tasks that must be done, and up to one mutually exclusive task must be chosen. So either 0 or 1 can be chosen for that. And then lastly, when choosing a task, that's going to be a binary variable, 1 meaning it was chosen, and 0 meaning that task was not chosen. For the graphical user interface, the GUI, I believe that I've added quite a bit of usability for the user. The user has the choice of importing data or manually entering it. Many navigational buttons are on the forms that the user can use to navigate through the system clearly and concisely. There's clear instructions on the forms and the screens, and there's also error checking, which accurately notifies the user of what needs fixed if they type something in wrong or make a mistake. The impact of this project is that I believe it would benefit the governments, not just the US government, but other governments greatly as a tool to determine which tasks to complete given their budget and other constraints. With many constraints to consider, this DSS could be improved to consider more constraints like labor, time, and other resources used. Governments have a lot of tasks that they need to handle and get done, so this tool would really help them decide which ones need to be done first and which ones to prioritize over others. Also, for me personally, I think the impact is that this is a tool that could benefit me in my future job at Ecolab, just assisting executives or managers within the company to help them to minimize the resources, well, basically get the best out of the resources that they have to maximize the benefit or gain of the task that they want to get completed. So this is the source of the DSS example that I chose. And next we will go into a demonstration in Excel and VBA. So now here we are in our Excel demonstration. As you can see, here is the initial screen that the user will see with the problem description, and they can click Start. Then they have two options: to read data from file or manual data entry. If they don't click either, they will get a warning that says they should choose one of the options. So for the manual data entry, let's click OK. Choose the number of tasks up to 10. So let's do 5. Evaluation measures, let's do 3. And now, as you can see, we jumped over to the manual data entry screen, where it has populated the budget requested for the 5 tasks, the 3 evaluation criteria, and the score tasks. So budget requested, we can just type in how much budget is requested for each of these tasks. Next, we can do the evaluation criteria, whether that's time, labor, energy. We can give this a weighting factor depending on how important it is to us that these criteria are considered. So time's probably very important, labor, energy. Next, you come down here. As you can see, it populated time, labor, and energy down here. So you score the task from 1 to 10. So this would be for task 1, how well does it do on time? How well does it do on labor? And how well does it do on energy? The higher the number, the better it does, because after all, this is a maximization problem. So then for task 2, you enter the same, and basically you just want to get all your values in here. All right, and once the user types in all of the values, they can go up and hit the solve button. And from here, they need to type in their total available budget. So let's just say the available budget is, let's say $2,000. Let's say they have must funded tasks in which they must fund, and then mutually exclusive tasks, and they can choose as many of these as they want. So must fund means it must be funded, and the mutual exclusive means only one of them may be chosen. And as you can see, so let's just choose 3 and 4 to make sure that only one of those is funded and that one is guaranteed to be funded. Now, if we go to solve this, we did not click enter. So there's a warning that says you must submit for the must-have tasks in these as well. Also, if I don't have anything in here, try and solve, another error check, it says it's blank. You type some letters in there and hit solve, it says it's not numeric. So you want to make sure you're typing in correctly, and luckily we have error checking that assists the user in that. So now you click solved. Oh, didn't hit enter. Now you hit solve. Calculation successful. See analysis button, and as you can see, the hidden button before is now available for us to press. So now we can see the results of this. We can see the tasks that were chosen were 1, 2, and 4. And if you remember, the must-have task was 1, so it did choose that like we wanted it to, and mutual exclusive was 3 and 4, so only one of 3 and 4 could be chosen. And as you can see, it did that. Total score is 97. And the budget spent was $1,900 out of $2,000. So pretty good. We saved $100. Now, if you want to see the brains behind how this works, you come down here. It's actually hidden. We have all the tasks and their appropriate budget. It's basically a solver maximization problem, but we have it hidden, and it will be populated from the code, the VBA code. So next, we can hit end. It'll send us back to the start screen. And real quick, I'll just show you the read data from a file. Once you type the file, you got to add the name of that file and .txt. Hit OK. And then, as you can see, this data is populated here. You've already got your budgets. It's 5 tasks. It's already scored them, it's already given them weights, it's already given them names, and it's given them the budget requested for each. So now, if you want to hit solve, just as before, you can add the available budget. You can choose the tasks that must be mutually and must have, and hit solve. And now the analysis button, as before, is popped up. So we can view which tasks have been selected, the scores of those tasks, and how much was spent. So thank you for watching. The VBA code is also available inside of the file. This was a very interesting project to make, and I enjoyed making it. So thank you. Have a good day.